Hello, I'm Dr. Valentin Voroshilov. I've been in the field of education for many years, playing many different roles. I was born and grew up in Russia. I had a pretty good career in Russia, but when I got a chance to move my family to the US, I took that chance. After starting again from the bottom, I have regained most of my previous career achievements. I'm pretty proud of this, considering I had no formal education in English and no professional network to support my efforts. And I believe in the existence of such framework. I want to start it from making two statements. Physics is a science. Teaching physics is not. Of course, these statements are based on a certain definition of science. Personally, I don't like descriptive definitions like the one on the left. This is, by the way, the top result of Google search for definition of science. In fact, such a definition doesn't really allow to distinguish a science from a religion. I prefer operational definitions like the one on the right. In particular, that definition allows us to see when a school of thoughts becomes a science. For example, astronomy dropped astrology and became a science when Kepler finished his analysis of huge amount of data collected before him and wrote his famous laws. Of course, in reality, there is always back and forth between theorizing and data collecting, or as we call it today, data mining. But in the end, every science is based on a solid foundation of the results of intensive data mining. If teaching physics is not a science, can it become such? Of course, all we need is to mine a lot of reliable and comparable data. I want to stress the latter word, comparable. Educational data mining is a young field. It starts producing a large amount of data. However, having a lot of data without being able to make a comparison is like using different currencies without establishing exchange rates. The history of physics shows us a means for establishing the comparability we need. Such means are called standards. We would have never had a hadron collider built in Geneva if, after an almost 100-year-long journey, physicists wouldn't agree on a set of common standards. There are standards in education, too, but when an educator says a standard, he or she means something very different from what it meant in physics. In education, a standard is a description of learning goals for what students should know and be able to do at each grade level. However, people using the same educational standards still can use different measuring procedure, leading to incomparable results. Based on those results, all we can conclude so far is that if we take two large groups of similar students, and one group of students will have a more extensive or diverse learning experience, for example, more contact hours or more time spent on certain exercises or training through more different exercises, etc. Students from that group, on average, will demonstrate better learning outcomes than the students in a controlled group. This conclusion becomes almost obvious if we employ the notion that the brain is basically a muscle or a collection of muscles, the development of which strongly correlates with the variety and intensity of the exercises it goes through. In order to move beyond the obvious, we need to adapt to teaching physics the same approach which had been adopted to doing physics. We need a standard which, like in physics, is an actual object or a feature of an actual object, accompanied by specific procedure which allows comparing similar features carried by other objects with the one of the standard. That's why a standard also called a prototype or an etalon. For example, a standard of mass is an actual cylinder. A verbal description, such as a sentence on the right, cannot be used as a standard because it's impossible to compare a mass of an object with a sentence. I believe that a standard for measuring learning outcomes must satisfy the following 5 conditions. Every aspect of the development of the use of the standard has to be open to public. The use of the standard must lead to gradable information on students' skills and knowledge, and also must not depend on any specific features of teaching or learning processes, and also must allow to compare on a uniform basis the learning outcomes of any student, and any institution adopting the standard should automatically become an active member of the community utilizing the standard, and can propose possible alternations to the standard to accommodate changes in future understanding of what students should know and be able to do. And I'm using this professional development event in part to find people who share the same belief. I have more than just a belief, I have developed a specific approach which will lead to designing such a standard. The approach is based on using MOCs. MOCC stands for a map of operationally connected categories. The link on the screen leads to a detailed description of what MOCC is and ways to use it. I believe that the time has come to create a coalition of individuals and institutions which goal is to developing the universal standard for measuring learning outcomes in physics, for starters. And that is one of the reasons why I'm attending this conference.